Right, so section 3.2 is more about parabolas and quadratic functions. So in section 3.1, we looked at the standard form of a parabola, and we looked at the factored form equation for our quadratic function. And now we're going to add another one. So we're going to add the vertex form. So you might remember from before that if this is our parabola, our vertex is where our function changes direction. Right? So either from decreasing to increasing, or if this was the shape of a parabola, from increasing to decreasing, it would be up here. Okay, and so this is where we find either our max or our min for this type of function. So this vertex form is y is equal to a times x minus h squared plus k. And a, h, and k are all constants. Okay, but we have the same restriction as before with the other forms. A cannot be 0. Okay, the reason for that is if a is 0, then this whole term goes away and we don't have an x squared in here anymore, which we need to get that quadratic piece. So there's good reasons why a can't be 0. H and k can be 0. That's totally fine. And let's take a look at what h and k are doing. So the vertex is located at, so this point here, is the coordinates for it are h comma k. So that would make this our h, and this would be our k over here. So our x and y values. Now the axis of symmetry, so what that means is if I put a line here, and I were to fold this function in half, it would look the same on both sides. Okay, so it's a mirror image. And the equation for this line here, so this is a vertical line, so it's going to be x is equal to, and the x value that's here is this h. So we get x is equal to h is the equation. All right, and this is a little bit of review from section 3.1, but we're going to add a little detail to it. So if a is greater than 0, so a is that number that's out in front of our x squared, then our parabola is going to open up like this one does. And when it opens up, it means that the function is concave up, so we have that bowl shape. And the vertex is always going to be a min in that situation. And then if our a is less than 0, so we have a negative a, it's going to open upside down. So it's going to look like an umbrella. So we get that our parabola opens down. And that umbrella shape is telling us that we have concave down. And then our vertex is going to be a max. You can get all of that just from that a value. So whatever number is in front of where that x squared is going to be. All right, so let's give this a try. We have two examples here. So if y is equal to x plus 3 squared minus 4, we're going to figure out whether it opens up or down, the concavity, and whether our vertex is a max or a min. So in order to get started on this, I want to look at what my value of a is. So this is a times x minus h squared plus k. So I don't have a number here, which means then that a is just equal to 1. And 1 is certainly greater than 0. So that means that my function opens up, and it's going to be concave up. So it's got that bowl shape. And that means that my vertex is a min. And now let's get the coordinates of that vertex. So this is written as x minus h. So this is x minus a negative 3 here, so that we get that x plus 3. So my h is negative 3. And then my k here, so this is plus k, so this would be plus a minus 4. So my k is negative 4. All right. So that gives us, just looking at that really quickly in vertex form, gives us quite a bit of information about what this is going to look like, which is great. All right, and then number 2, a is equal to negative 1/8, which is definitely less than 0. So that means this is going to open down. And that means my function is concave down. So I get that nice umbrella shape. And my vertex then is a max. And let's put our a x minus h squared plus k up here. So these signs all line up this time, which is really nice. So my h is 5. And my k is 1. All right. So that's one way that we can make really good use of that vertex form to give us good information about what our graph is going to